All right, this lesson is about physics, about the different field forces, how they work, and what equations to be familiar with. So, field forces are basically forces that can act over a distance. They don't have to actually come in contact with another object. Uh, there are four of them, and they're the four strongest forces known to man, besides love and God. But beyond that, uh, but gravitational, electromagnetic, strong, and weak. There we go. So we have an example here of like Earth and the Sun, and they're not touching, but they feel the force of attraction towards one another. Magnets would be an example of the electromagnetic, where they don't have to physically touch, but they can feel the force um, of attraction or repulsion towards one another. So let's look at the similarities and differences between gravity, electromagnetic, strong, weak nuclear forces. So gravity is the weakest out of the four. Even though it's super strong, the other ones are much stronger. The strongest ones are actually the nuclear forces, followed by the electromagnetic. Um, Gravity can act over very large distances. For example, like the sun and the earth are being attracted to each other, and they're millions upon millions of meters apart. Magnets also can act, or electrostatics can act over large distances. The difference here is that the nuclear forces can only act over short range distances. They can act over a distance, but really just this distance of the nucleus. Those forces start to break down at very, very small ranges. Gravitational forces, they only can attract. Uh, Same with nuclear forces, they only attract, they only hold things together, where electromagnetic is the weird one here, where they can attract or repel depending on what charges are involved. Like charges will repel, opposite charges will attract. Now, they're all different in what they act on, in essence, I guess. Gravity acts on masses, so two masses are attracted to each other. Um, Electromagnetic works on charges, meaning that it acts on different charged things and has no dependence on mass, whereas the nuclear forces acts on nucleons, and we'll talk more about that later. Those are just particles in the nucleus. A lot of times, gravity is simulated with curving space. Um, you can also think about that in terms of electromagnetic too, but it gets a little weird. And if you take any relativity or astrophysics, then we go into much more in depth about that. But um, that's the similarities and differences. Moving on. Now, the IB formula packet does talk a little bit more in depth about nuclear physics, and there's a whole section about like these different forces. And the way this chart works is that these are the particles that experience these different forces. So every single particle in the known universe is affected by gravity. That's what that means. So every single particle, as long as it has mass, is affected by gravity. But only quarks and leptons are affected by the weak nuclear forces, and only quarks and gluons are affected by strong nuclear forces. We'll talk more about that. And only charged objects are affected by the electrostatic or magnetic forces. Um, Now, particles mediating, what this means is there are certain particles that actually are thought to produce these forces. Gravity is thought to have been made by the graviton, um, which not as a lot known about the graviton, but it's basically a particle that scientists believe causes gravity. Um, these are bosons for the weak nuclear forces. We'll talk more about bosons in a bit. This symbol represents light um, or waves. So basically, electromagnetic um, particles that emit or whatever produces the electromagnetic forces are electromagnetic waves. Um, and we'll talk more about that later. And then gluons emit the strong nuclear forces. Now, we're going to talk more about gluons in a bit here, but we'll come back to that. Now, here's some different equations and concepts to think about uh, dealing with these different field forces. So, for example, a lot of things that come up in physics